Good morning, and welcome to this session on cloud security, where we'll be looking through a series of myths, investigating those commonly held myths about cloud computing and security. My name is Elliott Young. I'm from part of EMC Consulting that specializes in cloud and virtual data center consulting. And my role is to oversee delivery of real-world projects. So I don't have any marketing or sales slides to show to you today, but what I do want to do is to share with you some examples of projects where customers have been working on their journey into cloud technology and share with you some of the learnings and experience that they've got from that kind of work. So why EMC? Well, I can tell you internally, EMC is absolutely obsessed with cloud technology. One of our R&D projects, which is specializing in cloud, has a budget of $900 million for that program. So we're completely obsessed with it, and that doesn't even take into account other EMC companies such as VMware, RSA, Digital Fuel, those kind of companies as well that are also doing their own research and development in this area. Now, before we start looking at some of the myths, I want to start out with some definitions so that we're all talking about the same kind of language. So what are the characteristics that make up a cloud? What is a cloud? Well, typically, people talk about these 5 areas, and I want to pull out just 2 of those main points for this presentation. The first one is about self-service. So the users of the cloud solution are going to expect to have the ability to create their own functionality when they want it on demand in an automated fashion. The cloud solution also needs to be elastic. So elastic computing is good when the system self-detects the fact that it needs to expand to accommodate any kind of increase in demand, but it also has to be able to contract somehow. So that contraction is difficult unless that's designed in advance. And these are some of the kind of topics we're going to explore here. So how do you provide these kind of services? Well, people often talk about these different service models: infrastructure as a service, platform as a service, software as a service. And this slide shows an overview of the organizations that are working in each of those different areas. But for the purposes of this, I want to actually drill down into 4 different types of cloud. So what are the 4 main different types of cloud? Well, the first one is pretty obvious. It's a private cloud. And it's a cloud solution which is operated solely for your organization. And it can be in-house, it can be at a third party, but it's just for your organization. The public cloud solution is the one that everyone's familiar with, open to the general public. A community cloud is where several organizations, typically education organizations or local government organizations, get together to share functionality. And the last area there is a hybrid cloud, where you're looking to implement more than one of these different approaches at the same time in a hybrid cloud solution. So what do people typically use these approaches for? Well, in this slide you can see the main areas. As expected, we've got public cloud, mail and collaboration. Down in the private cloud area there's enterprise systems. But there's a small gap in the middle there that says hybrid cloud. Well, actually it turns out that from a business case point of view, the hybrid model is a sweet spot for cloud operations. This gives the biggest return. We did some work with McKinsey. McKinsey analyzed data from Gartner, and what they found is that in terms of developing a cloud strategy, you can look at a pure private cloud solution, and yes, you'll save money. Same with public cloud, but actually it's hybrid cloud that gives the biggest benefit. What sort of benefits? Well, we expect an overall IT spend reduction of about 25 to 30%. And this should be the target you're aiming for. It's quite a significant saving. The question is, can you do that? Can you implement this in a secure way? So let's talk about security. So if I was to talk to you about security, what 3 words or 3 letters come to mind whenever you think about security? Well, an easy way to think of this is the government organization in America, which is the CIA. In this case, CIA stands for confidentiality, integrity, and availability. So let's take those 3 words or 3 letters and put those down. Now, what other 3 letters do you associate with security? Well, in the cloud space, there's a lot of emphasis at the moment on governance, risk, and compliance. So if we put those letters down and put them together, what you come up with is the EMC and RSA Cloud Trust Framework. And this is a framework with lots of details and collateral behind each part of these 14 segments, which you can get from the RSA site. But use this to evaluate your current security posture and then the requirements that you have for security when you move into a cloud model in the future. So we've talked about the different types of cloud. We've talked about the approach to security. Let's explore some of the myths. And I'm going to do this using a structure which you may have seen on a particular TV program, where we look at a myth. If it's confirmed, if it's agreed, we say it's confirmed. If it's completely wrong, we say it's busted. And if it's somewhere in the middle, that counts as plausible. So myth number 1, I can only move new services to the cloud. I've got too many legacy services and I don't understand the security implications. So imagine this scenario. You're working for a large organization, you're the CIO of that organization, you don't know what's installed. You may have a CMDB, you may not. If you do have one, it might not be up to date. If you know what's out there, then how busy are those components? Which of those components should you move into the cloud first? What do those components talk to? If you're going to move something into the cloud, you need to understand the dependencies. And the approach to look here is something called automated blueprinting. Now, what automated blueprinting does is it gives you what I call the crown jewels of the data for your organization. This is the absolute fundamental data that you have to know how to best take advantage from cloud computing in the future for your future strategy. The way it works is you deploy technology on the network, which is agentless. You don't have to install any software on your servers. And each time a device is active on the network, it's automatically captured in the database. And the database is updated with details such as the configuration, the workload, and the connections that server is making. And that means that once you understand that, you can say, actually, I'll take the most inefficient services and move them to the cloud first to get those advantages. Or I'll take the most complex environments that I really don't want to have to support anymore and give those to someone else to support. So how does this work in practice? Well, if you imagine that this plate of spaghetti with meatballs is a bit like a typical IT environment. You know, if we consider, let's take the case of a data warehouse, for example, one of those meatballs could be like a data warehouse. So if I was to plunge my hand into that plate and pick up one of these meatballs, I'd have all bits of spaghetti hanging down from it. It'd be pretty messy. If I wanted to put that onto a brand new clean plate, what else would I take with that meatball? It's a bit like moving the data warehouse environment into a nice, shiny, new cloud solution. You know, if I'm going to move a data warehouse, I need to consider what effect it's going to have on the systems that feed the data warehouse. Perhaps it's doing lookups into Active Directory. Perhaps it's got a connection to the backup server or connections to more database servers. You know, if I don't do something to those connections, then when the database service gets into the cloud environment, something's going to break. So I need to have that kind of understanding. And this is what blueprinting does. It gives you that kind of understanding. Let's have a look at some real-world examples. So in this case, the data has been put into a simple Excel system. And we can see down here that these are real-world names of systems that a customer has got in their environment. You know, there's not lots of technical server names or IP addresses. It's something that you can read and understand at a glance. And here we can see that the cache register access gateway system is actually making connections to Active Directory, real-time processing system, and a login system. Why is it doing that? Well, it's because there's a DNS server that it's connecting to. And in fact, we can see down here, the electronic funds transfer server is talking to domain controller 1. So this is real data, updated automatically on a daily basis that doesn't require any manual intervention, which you can use to start to plan your journey into the cloud. But what if you want to do something that's a bit more complicated? What if you've got data centers spread all over the world or in different locations and you want to run some complex queries? Well, in this kind of solution, you can click on these individual boxes and get the results filtered over here to see which systems are affected. So you might say, for example, actually, I don't want to do a tech refresh on all of my Dell servers. What I want to do is take the services running on the Dell kit and move it straight into a private or public cloud solution. So in this scenario, the user has selected the Dell kit running Windows 2003, located in Argentina, and here's the systems that are affected on the right-hand side. So this is giving you real, usable data. But what we haven't talked about is security, and of course that's the topic that we're discussing in this presentation. So before moving your services into the cloud solution, it's important to understand the security implications. If you're working, for example, in a PCI compliant environment, then your systems need to be segregated. The last thing you want to do is to take problems from the existing system and put them into the new cloud solution, because inevitably your cloud migration project will get blamed for causing these security problems. So up here we can see that there's an external PCI compliant zone talking to a non-PCI compliant zone. So why are those 4 connections happening? You'd want to investigate to find out more about that. Down here we can see that somebody's drilled down to see that there's an Oracle server. Lots of Oracle servers actually in this environment. So you might say, for example, actually Oracle costs, they're quite high. To get a good business case, I could take all my different versions of Oracle and put them on the same physical hardware. With a virtualized cloud solution, you can do that and only pay 1 license cost. And you haven't upgraded Oracle, you haven't standardized the versions, but you've still got a huge saving from doing that. So you can start to get this kind of information out of the system. One of the most difficult things that we find when people are moving to private or hybrid cloud solutions is understanding the security firewall rules. Imagine your firewalls, the configurations have probably been building up years and years, year after year. And if you were to go back and say, tell me all the ports I need to be open for this particular application, there's not going to be one document that you can say for sure is up to date and completely accurate. So what you can do is use your crown jewels blueprinting data to get that data, to say, actually I've measured the ports that are in use and these are the only ones I'm going to put in my new cloud solution. So in this case, to move the data warehouse, I know that there are 17 connections within the same zone, so I don't have to worry about those, but I do have to open up these ports 53, 123, and 1521. And what's the reason for doing that? Well, it's because there are DNS lookups going on between the data warehouse and domain controller 1. So again, this is real observed, measured data which you can use to provision your new environment. And there are other approaches as well. So from a security point of view, don't think you'll be able to support new cloud solutions in the same way that you support existing server farms. The obvious one is around self-service automated provisioning. What do you do about managing that process? Who do you give access to be able to create their own service? Now, you don't want to reinvent the wheel, so there are a number of different solutions that you can buy that already have these processes automated, which you can deploy as part of a tool with those workflows. It's also an opportunity to look for what I call hyper-consolidation. We were doing some work with a leading airline in the UK, and they came along and said, hey, we've got this data center. There's 300 servers in it. They're all HP DL380s, that kind of thing. We know that we need to consolidate them down as we're building our private cloud infrastructure. How many new racks are we going to have to deploy to host this new cloud? And there was someone from this company there at the meeting, from the VCE company, and the VCE man said, well, we're going to need a new rack. And they said, yes, we know we're going to need new racks, but the question is how many? So the guy said, no, you don't understand. We can take all of your 350 servers, all of your SAN switches, all your network switches, all the fibers, all the cables, all the power supplies, all the hard disks, and with hyper-consolidation, put them into one rack. That rack is completely virtualized, and that will be the start of your private cloud solution. Of course, when they heard this, they were very interested in pursuing that kind of technology. So, myth number 1, I can only move new services into the cloud. I'd say that myth is busted. Myth number 2, I can't comply with data security standards using cloud technology. Well, this is an interesting myth. If we look at concerns from research, then this still remains a major area of concern. Here's a heat map, which has come from McKinsey, and you can see public cloud, lots of red boxes, is the framework we talked about before. So there are some very real concerns about that. But to help, there's plenty of guidance. Now, on the next couple of slides, I don't expect you to read all the words, but these slides will be available afterwards, so you can refer to these. There are regulations that apply. If you look at, for example, 27001, that's a measurable standard that you can adhere to. 27002 tells you how to achieve that standard. That's the advisory. If we take the example of PCI compliance again as one of the bottom points on that slide, then you can see that that standard has actually been updated recently to take into account cloud computing technologies and extreme virtualization. Previously, you had to have things segregated onto different hardware. Now what we're looking at is the scenario where you can have multiple different services running on the same physical hardware and still be PCI compliant. You can also do that with third-party cloud providers. And the key point there is that service providers can achieve the verification themselves, or they can piggyback off the back of your verification. The problem with that is that that adds additional cost to you. So in the next myth, I'll talk about ways to reduce that cost. So I'll say for this myth plausible. You do need to go through those individual regulations. Myth 3, data in the cloud can't be trusted. How can I keep my data confidential? Well, we could spend all day talking about confidentiality, authentication, authorization, approach to hacking, vulnerabilities. Instead, for this session, I'm going to propose some alternative approaches. And the first one is tokenization. What tokenization does is it says if you've got some sensitive data that you want to give to a third party to host for you, you can strip out that sensitive data and replace it with a token. So let's take, for example, the case of a credit card primary account number. You can replace the credit card primary account number with a token which looks like a credit card number, but it's not a credit card number. That means if that data is compromised in the public cloud, all the person gets away with is a list of things that they think are credit card numbers but are not. The only time that that turns into a real credit card number is at the point you actually need to execute a transaction where there's a completely separate system that changes that into an active credit card which you use in your own systems to process that transaction. So that's a good way to reduce your exposure. It also means that you can avoid having to be compliant in different areas when your data is in the public cloud. Next point is about teleportation. Now, teleportation is a technology which extends, well, in the VMware world it would be vMotion, but extends it to long distances. And I'll talk about that more in the next myth. But the key point about that is that it allows services to run in the public cloud, even though the data that's associated with them is still in your private cloud. So that way you haven't actually copied the data to the public cloud. Next point is about data loss prevention. So there are lots of different products for data loss prevention, but the key thing here is that you train that system to look for data which is important to you or confidential to you. And it scans the data that's being transmitted, the data that's stored in online systems, storage systems, SharePoint, that kind of thing, to highlight areas where you may be leaking data from your environment. So myth number 4. Let's go straight into myth number 4 now, actually, to talk about teleportation, because this is how you can get the benefit from hybrid clouds. The idea is to take a service whilst it's still running and move it into the public cloud without any service interruption. If you want to do that with typical virtualization technologies, that's not an easy thing to do, because if you want to change something from London to Germany, it's going to get a new IP address, there are going to be all kinds of extra updates, the data won't be in the right place. So how do you achieve that? Well, I've got 2 examples. So the first one here is where within your London part of your private cloud, operations, VMs, workloads are naturally jumping around between different points. And that's enabled by technologies such as vMotion. What we can do is take just the cache component and have that replicate to another location. That means you can take a running workload and move that to a long-distance site, still within your private cloud, but have the storage remain in London. And optionally, if you want to, you can then have that storage replicate across to here, so that eventually 100% of the service is running over here. But the good thing about this is it gives you the flexibility to run your operations from any site over long distances. Let's have a look at this second example. This is where one of our clients was using high-performance computing environment. It's a big pharmaceutical company, and they wanted to run simulations of their drug performance. And the way they do this is they take a job and they run it inside their private cloud. And that job turns into a job running on a particular virtual machine. And because of their grid environment, they're able to scale it up to, let's say, 50 devices, all working on understanding the answer to this one question. So they would start this on a Monday, it would run across to a Tuesday, they still haven't got the answer. But then what would typically happen is someone from the business would come to the IT department and say, disaster, we've got job 2 is absolutely critical, I really need to know what the answer to this job is. Now here's a dilemma for the IT department, because if they stop the processing running on these 50 nodes down here, they're going to lose 2 days worth of processing. So what can they do in this scenario? Well, what they can do is, because they've already worked with their public cloud service provider, they can establish cache consistency and take that workload as it's running and move it into public cloud. But this is not like vMotion or some kind of normal transfer. This is going to take a consistent state of all of those 50 machines at the same time, move them into the cloud. That allowed them to put in job number 2 and start that up on the entire set of processing power available in their private cloud. That allows them to get the data out nice and quickly, get job 2 results, which means that subsequently they can then take the jobs that were running in the public cloud and run them back in the private cloud until that job completes. This means they've only used public cloud processing capabilities when they needed to use it for the smallest workload to get the biggest benefit. So in summary, what this is saying is that the key thing here is when you're developing your cloud strategy, design the solution in such a way that you can take advantage of public cloud capabilities as well. And the best way to do that is to go to your public cloud provider and ask them what technologies do they use to run their systems. Because if you use similar technologies, you've got some level of assurance that your internal private cloud will be compatible with public cloud in the future. So I'd say that myth is busted. Myth 5, my apps won't run both locally and in the public cloud. So why would you want to do that? Well, we've talked about a scenario just now of why you'd want to do that, but you'd also want to do it from a security point of view in case that service provider fails. You want to be able to get that back. You also want to be able to take on the elastic nature of cloud computing. So we're going to talk about one approach here. There are lots of different approaches, but this is an example of where you'll be building an application. For example, you want that application to run in the Google Cloud, but it can also run in-house. Let's say we're building a web ordering system linked to a fulfillment system. You launch a promotion, and as the sales take off, you spawn up new instances in the Google Cloud, as well as on your own in-house servers. So imagine the complexity of that application if you developed using traditional ways. What you have to do is have the application aware of where it was running each time it wanted to do some kind of action, such as get customer details. If you want to get customer details, if it's running in the Google Cloud, it has to look at security in a completely different way. It has to look at where it's going to get that data from. It might be completely different database technology. If it's running in-house, perhaps the security is already automated and there's pass-through authentication which allows it to get that data immediately. So that kind of complexity takes away from the functionality that you're trying to develop from your cloud solution. So if you were to use a framework such as the Spring framework, the capability to run applications natively in the cloud is already built in. And the way it works is this. When you want to scale up the application, let's say you want to scale up some new instances in Google, the individual components come up and they are aware of the environment they're running in at the moment that they are brought up. And this is the concept of dependency injection. This means that you can concentrate on testing the functionality of the application and you don't have to worry about where it's running, either in a public cloud or a private cloud, because the same software solution can get its data from a Google data store, MySQL, or from an Oracle database, in this example. There's lots of information on the web about these different aspects here, but this is just a taste of the kind of approach that you can use here. Now, this approach is being used extensively by large organizations. This is an example of one of them. I'm not suggesting that Barrick is coding his own lines of Java, but he could if he wanted to, I guess. So, myth number 5, myth busted. In summary, there's some very valid real concerns about security and how do you practically get your existing or legacy systems into a cloud environment. But there are always ways to mitigate those kind of concerns. So what are the typical steps you should take? Well, step number 1, I'd say select a partner for your cloud journey that can demonstrate the actual capability. Get some examples of where they've done this before and make it specific to your own cloud vision. Not everyone is going to get all the benefits of cloud right from day one. You need to work out which benefits are appropriate to you and what's the quickest way to realize those to fund future work and future cloud expansion. The way EMC does that is we start up by looking at requirements, go into an economic evaluation, and then put that through a filter that says, well, do I trust this environment? Is it appropriate to run it in public cloud technology or private cloud technology? And at the end of that, you come up with a recommendation that's specific to that organization. And then turn that into this kind of heat map that says, actually, if you look at the systems that you've got, here's how they would perform on a red, amber, green scale for typical criteria. So imagine if these were your applications across the top here, you could start to make some informed decisions about which applications to move into the cloud. Step number 2, you must carry out the blueprinting or discovery. This is absolutely critical to get some real-world numbers. And you actually want to be able to say, I've analysed this situation and I can expect to have a particular number associated with these savings or these benefits, as well as the intangible benefits as well. Step 3, future-proof your architecture. So what I'm saying here is that whether you start out with a private cloud or a public cloud strategy, that might not be where the aiming point is. So make sure you design in the ability to have a hybrid cloud solution in the future, should you need to use that. For more information, there's lots of details on the website, or you can contact me directly. There was an interesting article in Computing recently where KPMG were talking about exactly this kind of thing that they've done. So there's a real-world case study for you. I'd be happy to answer any questions, probably outside after this session. And that's it from me. Thank you very much.